In this video, we'll discuss the proof of binding energy, the energy needed to split a nucleus out of a fission nuclear reaction with uranium-235. When the nucleus of U-235 absorbs a thermal neutron, it grows larger and becomes unstable. The strong force that holds the protons and neutrons together breaks down. This leads the nucleus to split into fission fragments of smaller nuclei such as barium-144 and krypton-89, along with 3 neutrons and a release of gamma particle or a gamma photon. Gamma emission is released when an electron transitions from an excited state to a lower state. But the big question is, how much energy do we need to break the nucleus? Diving into the math, the initial mass of uranium-235 and the neutron is approximately equal to 236.0525 U, which is larger than the final mass for the fission fragments, which is approximately equal to 235.867 U. The mass difference is called the mass defect, which is approximately equal to 0.185 U. Physically meaning, the mass defect is the difference between the sum of the masses of nucleons taken separately and the mass of an atomic nucleus. This mass defect is converted into binding energy according to Einstein's energy mass equivalence. In other words, releasing energy to attain stability. The total energy is equal to the kinetic energy and the mc squared. According to the conservation law of energy, the total initial energy is equal to the final energy. The kinetic energy of uranium and its initial mass multiplied by c squared is equal to the total kinetic energy of barium, krypton, and the 3 neutrons, and the final mass multiplied by the speed of light squared and the energy of a photon, which is Planck constant multiplied by the speed of light over the wavelength since it has no kinetic energy for being massless. The kinetic energy of a uranium is 0, since it was at rest having velocity to be 0. By taking the final mc squared to the other side, we end up having a mass defect multiplied by c squared equals the total kinetic energy of the products with the energy of gamma. And the multiplication of mass defect with c squared is what we call energy liberated or the binding energy. This was the behind the scenes of the binding energy, and thanks for watching.